Good afternoon. My name is Iyesomi Maureen, and I'm here to deliver a presentation titled Contrustion Robots, a lasting solution to infrastructural development. While the content of my presentation is based on research I'm currently carrying out, exploring the use of robots to solve infrastructural problems. But for the purpose of this presentation, I would like to narrow down on one particular kind of infrastructure, which also doubles as one of the most fundamental physiological needs of man, according to Maslow's hierarchy of needs, and that is shelter or housing. Housing, as you can see, is as important as food, air, and water is to man. Why? Because every man needs a roof over his head to protect him from the elements. But it might surprise you to know that almost half of the 7 billion people that exist on this planet live in the most deplorable housing conditions you can ever imagine. You see people go out in the morning, but you'll be shocked where they return to at night. And if you have no place to return to, then you must improvise. And this is what most of these people have managed to do, some even living under bridges. I want to help you understand the enormity of the housing problem that has forced individuals like you and me to resort to living in the nightmare called slums. While slums don't only exist in developing and poverty-stricken nations like most people believe, slums exist from first world nations to third world nations, as you can see on these slides. Now, coming home, this is a slum in the oil-rich Niger Delta region of my country, Nigeria. But unlike the pictures you just saw, this place particularly does not deserve to be a slum. You know why? Because it's responsible for 80% of the total revenue of the nation, yet its inhabitants are living like this. And this is the center for the passion for construction robots. In 2007, during my final year project in school, I was working on artificial intelligence and robotics. At the same period, the militancy issue killings and kidnappings in the Niger Delta region had reached its peak. And the reason was because of the injustice the wealth creators of the nation were suffering, lacking even the most basic infrastructure. Most people sympathized with them, but I decided to find out what the real problem was. And I discovered that not only is the region a slum because of lack of infrastructure, it is also a swamp. In fact, it's the largest mangrove swamp in the whole of Africa. And if you're familiar with swamps, you know that they're a very tricky and dangerous area. I remember the bomb blast that happened a couple of years back in Lagos. More people died from jumping into the swamps than those that died from the bomb itself. So no right-thinking civil engineer or builder want to carry out any kind of construction process in a swamp. So I started thinking, how can I help to solve the problem for my people in the Niger Delta region? How can I help to do something about it? And I realized that we can actually build robots that can carry out construction processes from start to finish with minimal or no human involvement, thereby protecting lives while still providing infrastructure in the region. And this is the vision behind construction robots. But before I go into how that can be done, I want to give you a few fast facts about robots generally so that you can understand the concept better. Well, the word robot originates from the Czech word robota, which means slave labor. Robots are simply machines that are imputed, please note the word imputed, with artificial intelligence to carry out tasks that man would normally have done. Now, these are surgeons carrying out an operation on a patient, and this is a robot carrying out the same kind of operation. All we do is that we take the knowledge from the experts and impute it into the robot, and I will show you how we do that as we progress. Secondly, robots don't have to look human, contrary to the movies and stuff you must have seen. Their designs are determined primarily by their intended functions. And number 3, robots are not there to take any man's job. They are simply created to perform what I call the 3 M's and 3D tasks. 3 M's meaning menial, monotonous, meticulous, and 3D's meaning difficult, dirty, and dangerous tasks. So robots are our slaves. They are there to serve human beings. So we can safely conclude, therefore, that construction robots are typical construction machines that are imputed with artificial intelligence to carry out construction processes that man would normally have done. Now, this looks like typical construction machines, but I want to surprise you that they are actually robots. That is the automated excavator of the University of Sydney, and that is the brick assembly robot used in the Roko project in Japan. Now, there's an issue in the construction industry that does not allow for complete automation of construction processes, and that is the unstructured dynamic nature of construction sites. Now, we're talking about housing. There are too many kinds of houses: 2 stories, skyscrapers, condos, flats. Where do you put a robot to start from? Don't forget, robots specialize in monotonous, predictable environments. So I come up with a very simple idea, and that is focus on one particular kind of construction structure or project first, automate that structure, and when we're successful, move on to more complex structures. And for simplicity's sake, I focused on the bungalow. With only With only one story, the bungalows are the easiest to build. They require the least material, they're economical, they're durable, they're compact. In fact, they're the preferred choice of most people. Like, I personally want a bungalow, but of course with a pool beside it. Anyway, now, in order for us to get robots to build a bungalow, we must take the knowledge from the experts and impute it into the robot, and we're doing that in 4 simple steps. First of all, we must identify with the professionals in the field, and these are the following professionals: foundation engineer, builder, structural engineer, electrical engineer, mechanical, and the artist that does the interior work. Now, these professionals must collaborate with a systems analyst who collects their expert knowledge and forms it into an algorithm. This is the second step and by far the hardest part of this process. Why? Because the algorithm must be comprehensive enough to contain every single step the professional would have done so that the robot would do it. And this is where most of the mind work goes into. Now, these are the typical expert knowledge you expect from these professionals: foundation laying, brick laying, roofing, conduit wiring, plumbing, setting ceilings and stuff, and of course, painting. Now, once the systems analyst collects this algorithm, he passes it on to a programmer who converts it into code using the programming language that will be imputed into the robot to perform. This is the simplest part of this process, and I'm sure you'll be wondering how. Well, it's as simple as translating English to French. Once you know the programming language to use, the algorithm, which is the hardest part, becomes very simple to do. Now, in the end, we end up having these different robots performing different tasks, like the excavator robot and the brick assembly robot you saw in the previous slides. But as they stand, these robots still exist as separate entities. What about the complete automation? And this is where most roboticists all over the world stop. I take it a step further. I'm creating right now a software that will be used to synchronize the activities of all these robots so that they can function as a single unit. Remember, our goal is minimal human involvement, and I call it the computer controller software. I'm going to be describing how it works, and in a couple of months from now, by God's grace, it should be ready. Now, what the software does is that it cues and activates each robot according to the process and time it should start. Now, we all know that to build any structure, we must lay the foundation. Now, the controller software calls in the excavator robot for the dig process. Next, it calls in the cement mixing robot to pour in concrete, and then it calls in the brick assembly robot to lay the foundation blocks. It does this sequentially until it gets to the final robot that is required to complete the task, as you can see. Now, when the software is finally ready, it will definitely enable remote control features so that man can control it from anywhere at any time. Now, the best part of all this is that if robots can successfully build one bungalow, then they can build 10, they can build 30, they can build 1 million. Why? Because robots specialize in monotonous, repetitive tasks. And in partnership with the government, we can actually put an end to the housing issue in a few short years by creating bungalows, low-cost, mass-produced, qualitative bungalows all over Nigeria, and of course, other parts of the world where these services are required, especially the slum areas. Okay? Another application area are the natural disaster victims. Thank God for relief materials, food and water, but many of them are still homeless till today. If we can provide houses for them as soon as theirs get blown away, then we can save them from lengthy post-traumatic issues that most of them face as a result of their loss. Now, this is my passion, the Niger Delta region. Okay? Now, we can turn it into a first-class estate. How? By the grace of God, the first set of these robots should be ready in the next 3 years. That's my target. And then we ask the government, give us land, give us building materials, and we're going to build free of charge for the Niger Delta region because they are the inspiration behind this project, and there will be no more excuse for lack of infrastructure. Other benefits include transparency of quality. Robots will not compromise standards. They are basically garbage in, garbage out. When the standard is put in there, then they perform it. And then we have reduction in death toll. Human lives are not replaceable or repairable, but robotic parts are. And then increased productivity. Nigeria is a consumer nation. I'm passionate about that. I want us to move from that to become a more productive nation, and we start getting more productive. And the best part of it is that this results in a whole new industry, a robotics technology-driven industry. Our young people start to program robotic parts and build the software and everything like that. And we become an advanced technology-driven society in Africa where people think that nothing really good can come out of. Well, this is not just abstract. This is Robot Tessa. She is a prototype of one of the robots that will be used to build the first completely automated bungalows in the world. The slogan for my research group is building robots that touch lives. Touching the lives of almost 3.5 billion people on this planet is not an easy task, but one I'm willing to undertake and live for. And by the grace of God, with continuous research, hard work, and support from organizations like the IET, I know that this dream shall become a reality. Thank you.